So I'm listening.
Okay, so you make your, well, I have to lay it out in columns. So I have do not use 158, sometimes 1,216, frequently 2,823. Then you add them up, so you have your total number of respondents.
Okay, so
4,197.
58 students, they do not use a credit card. 1,216 say they use it sometimes. Okay. What is it?
2,823.
So you add them all up.
Yep. Then to find out how frequently someone uses it for the frequently column, it's 2,823 divided by 4,197.
Divided by,
And that equals 0.673 with rounding, which is 67.3%. Use a credit card frequently. And then is it unlikely for someone to use a credit card frequently? It is not unlikely for someone to use a credit card frequently, and that's because it's it's greater than the 0.0.
That's very good. Very good. Perfectly done. Very nice.
I'm going to answer all the easy ones, and then Christy's going to do all the hard ones.
Great. I love a challenge.
That's saying a lot coming from you, Christy, because there would have been a time when you would not have said that. Nope. You would have been like, can I run away now, please? Yeah. All right. What about, how are we with number 2?
Number 2, constructs the sample space. Okay. So heads and tails in 3 tosses of a coin. So we're going to do all the combinations we can get with the coin.
Right. But there are 3 now. There are 3 coins, right?
No, it just says.
Yeah, there are 3 coins. Construct the sample space for heads and tails in 3 tosses. Well, you could do 3 tosses of 1 coin, but it's
the same thing.
It comes out the same as, there's going to be 8 combinations.
Okay.
Altogether.
So,
is this where we list it? Heads.
Yeah, so let me bring up a
heads, tails. I mean, heads, tails.
I would remember, I don't know if you remember that I should
You're
a Google Doc right now, so I can
Yeah, I need you to show. Yeah, I just where I get my stuff.
All right, let me get rid of. And let me share this.
I think I got them all.
You want okay, insert table. Okay, come on, people. There we go. 8.
Oh, I see. Okay, I get this. I'm remembering.
So this is heads, right?
Mm-hmm.
Then you're gonna go down in the 3rd column. You're gonna alternate every other. So heads, tails, heads, tails, heads. Oops, no. I don't want to replace it. I just want to see heads, tails, heads, tails. There should be 8 of them. 2, 4, 6, 8. Okay. Now this one the middle column alternates every 2. So heads, tails, tails. Then heads, heads.
Christy, did you get like 1 out of 8 for all heads and 2 out of 8 for 2 tails?
I didn't do that yet. For A and B.
Right? All heads or all tails is going to be 1 out of 8. Yes.
Okay. Oh yeah.
Okay, so it's 12.5% and then 25%.
So what, I don't remember what I'm still making the chart.
Oh no, I'm wrong. It's 3. There's 3 with 2 tails. So it's 3
Does
out of 8.
does it say at least 2 or does
No,
it say exactly?
it says exactly 2. So there's 3 out of 8.
That should be 3 out of 8.
So that's going to
Do
be
you
37.
see that?
Yes.
0.375, yeah.
Yep.
Mhm.
Okay.
Okay.
Christy, did you get that one?
Do you
I forgot how to figure that out. I mean, I know how to find out how many heads, so you just look at your combos, but then for the percentages, how are we doing the percentages?
So what I did is I list out all the combinations to see the way Shwana has it on the screen, where it's heads, 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 tails, heads, tails, heads, heads, tails, tails, blah, blah, blah. Then you look at which one of those has 2 T's in it. So if you look at line 4, it's got 2 T's in it. If you look at line 5, 6, it's got a T, H, T, so that's got 2 T's. And then the line below it has T and T. So those are exactly 2. So 2 divided by the total number of combinations, which is 8, or sorry, 3 divided by the number of combinations, that's 8, is 0.375. And then that's
Because there's
5%.
Because there's 8 rows, right, Christy? So there's 8 outcomes, right?
Okay.
And 3 of those outcomes contain exactly 2 heads.
Okay.
Or 2 tails, I mean. Well, they all contain exactly 2 heads.
So I guess I'm forgetting, the correct way to construct this is this little 8x3 graph thing?
You can do this, you can, or you can do the tree diagram, which I think you said he didn't show you.
No, but you
No,
showed
I
it.
did that on my last test though. For this.
If you need the tree diagram, I can draw it, but not on here.
Oh
But
no, okay. I'd rather do it like this. I feel like this looks more, I don't know, I can understand it.
And you can add a, if you want, let me add one thing here. Come on, there we go. Insert row, but you can add and say, first toss, second toss, and third toss. Now, sometimes it's easier if you construct a frequency distribution, which this is just like a sample. This is the sample space. This is the sample space for 3 coins. This is a representation of all possible outcomes. That's the sample space. I can take this and make a probability distribution from it. I can say that I want to do table here and do like, let's see, I think a couple of these. So if I did like X, and I did P of X, and I did a row above here. So I do insert row above, and I do like number of, let's say you want to make this tails. You could make it number of heads as well, but you're looking at the number of tails. So if you did that, you'd have like, 0, 1, 2, 3, then the probability of getting 0 tails would be all heads. This is the same thing as all heads, right?
Mm-hmm.
So all heads is that first row that you saw. So it's 1 out of 8, right?
Mm-hmm.
Then one head means the number of rows on which you see exactly one H. The number of rows on which you see exactly one H. Well, there's one on row 4, HTT.
Mm-hmm.
There's one on row 6, THT. And then there's one on row 7, TTH. So there's 3 of those, right?
Okay.
So you have 3 of those, 3 out of 8. Now you already counted the one for 2 heads, 2 tails I mean, so that's 3 out of 8. And 3 tails would mean, or 3 heads, sorry, would mean no tails, right?
Mm-hmm.
And that's your 3, no heads, sorry. So this is because your X is the number of tails. So this means no heads. So this is that last line. So that's 1 out of 8. And if you look, 1 out of 8 plus 3 out of 8, that's 4 out of 8. 4 out of 8 plus 3 out of 8, 7 out of 8, 8 out of 8, they equal 1. So this is, if he asks you, you don't have to do this, but if he asks you to construct a probability distribution, this is a table that lists the outcomes of a random variable, in this case, the number of tails that result from tossing 3 coins. It's a table that lists the outcomes of a random variable with the corresponding probabilities of each. So you understand the difference between a sample case and a probability distribution? It doesn't have to be this. It could be some other, like, sometimes they'll give you like the probability distribution for, say, the number of like candies in a bag. There's so many red, so many green, and so many blue, whatever, you know. There's different ways of doing it, but that's sometimes if you make the probability distribution, it's easier to answer the questions if you're going to deal with it repeatedly. Okay.
Yep. Okay, so number 3 is going to be the same kind of sample space, but with only 2 outcomes.
So 3 is construct a gender for the gender outcomes of having 3 children.
Oh, 3 children, yeah.
So yeah, it's basically the same as what we did, except instead of TTH, you're going to have GGG, and yeah, so it's going to be very similar. Okay.
So then can we jump to 4?
Okay, but just make sure, because the questions are different. So make sure you understand.
So the first one is construct a sample space, you know, blah, 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 3 children. Okay, so if the outcomes are equally likely, find the probability of getting at least 2 boys. So it could be 2 or 3.
Right. So in this case, if you want to check that answer, you look at your sample space that you just created,
Yes.
And change or you can use the exact same idea as before.
Yeah, I made the GGG, GGB, GBG, GBB, BBB, BBG, BGB, BGG. And so 4 out of 8, which is 50%.
Right, because 2 boys is going to be 3/8, right?
Yep.
And 3 boys is going to be 1/8, so that's 4 out of 8. Okay, so it's different probabilities, but the same kind of
Wait,
idea.
figured out the same.
Yeah.
Okay.
And then for number 4, I made my chart. Then I remember us doing this, and I had I had no problem with A. But B was like, I forget how to do this. So.
Okay, so yeah, this is relating to So let me.
Oh, I remember this one.
So I did A fine, but then B I'm getting struggled on. So maybe you can help me, Christy.
Okay, if a staff person is selected, find the probability of the selected figures. Okay, you said A, what you were fine?
Yeah, so A is easy. A is the 8 out of 13 plus 3 out of 13 equals 11 out of 13 minus the one they have in common out of 13. So it's 10 out of 13. 0.769, 76.9%. That is a nurse or a male.
Okay, let me see.
And then the without replacement is a little trickier for me.
Okay, well let's go ahead, because Jane, you're doing really great. I think right now you're ahead of where Christy's at.
You are.
So
remember this one, I feel like we spent so much time on this, and I still am forgetting how to do the.
that's okay. We'll look at it. Hold on. So we have male, female, and we have doctors or physicians, I should say, nurses, and physicians, right?
Mm-hmm.
And I need a total, so I need a column here. Let me add a column. Insert row, no. Insert column, right. Okay, and I need a row down here. Insert row below. Okay, whoops. I'm gonna have to move that down now. So let me do that, because I need to move. I'm gonna add the whole problem in here. So let me just move all of this. I could have put a page break, but oh well. All right, so here we have, let me do something here. Okay, so can you see it now, both of you?
Yeah.
Yep.
Okay, so male, female, this is total here. And then we have total here, right? So when you have a problem like this, forgive me for stealing your thunder, Jane. I'm gonna
do it.
Back us up a little bit, okay? So before you start a problem like this, if it's given in this way, you should construct a table to help you organize the information. So in a hospital unit, there are 8 nurses and 5 physicians. So they're giving you the total. So 8 nurses goes in the total. If you happen to put physicians on top, that's okay. That's fine. 8 nurses, 5 physicians. Since you have both of these numbers here, you can add up the totals. 8 plus 5. So how you got that was, this is 8 plus 5. This is equal to 13. Okay? Now it says 7 of the nurses and 3 of the physicians are female. So you go to female, the column here, and you say that 7 nurses. So you go to the nurses on the first row, you go to female. So 7 of the nurses are female, okay? and 3 of the physicians are female. Does that make sense?
Mm-hmm.
Yes.
Okay, now, how do you get the males? Well, remember, you add these 2 numbers going across to get this total of 8. So, to get the male, you do 8 minus 7 to get 1, because 1 plus 7 should be 8. So, you're kind of doing this backwards, okay? And then, same thing here. So, 5 minus 3 is 5 minus 3 is 2. Oops, not 3, 2. So then now you have all of your numbers, and go ahead and get your totals. So 1 plus 2 is 3, and 7 plus 3 is 10. Okay? Now the other thing you should cross-check is to make sure that both of your totals going both ways match. So 8 plus 5 is 13 right here.
Yep.
And then this number, 3 plus 10, should give you 13. So your row total going across and your column total going down should match your grand total. If they don't, you've done something wrong.
Yes.
Okay.
Yes. I did mine opposite yours, but it's still accurate.
Questions on how I set this up?
I don't have any, Christy.
No, I'm good.
You're okay?
Yep.
All right. So A, if a staff person is selected, find the probability that the subject is a nurse or a male. So when you're doing or means, so we say the probability, I'm going to write the formula first and then I'll show you. So the probability, this is part, whoops. Okay, so we have A, the probability of being a nurse or a male. Okay, so when you look at nurses are all across the first row, right? And then we have male. Well, we have an overlap there, don't we? See, the nurses are this group. Let me see if I can highlight that. Let me use yellow for that. Okay, so if you look, you can see that the nurses are there. And then if I highlight the males, let me highlight that in a different color, like orange. So if you look here, now you can see that they overlap. The nurses and the male, they overlap by this one right here. They overlap right there. And I'm gonna make him, I don't know, let's make you green. Can I make it green? Yeah. So you see that? Does that make sense?
Yes.
Okay, so when I use or means we add, so we get the probability of being a nurse plus the probability of being a male minus the probability of being, the probability of being a male and, or actually I should, let me keep the same order, nurse and male. Are you okay there?
Mm-hmm.
With what I just showed on the screen? So now, not yet, not time for B yet. So the probability of being a nurse You take all your nurses, which are 8, and you divide by the total, which is 13. Remember, probability is not a frequency, okay? I have a lot of students tell me the probability is 8. No, it's not, okay? That's the frequency of nurses that you have, okay, or the count. A probability is a fraction or a decimal between 0 and 1. So your probability is not 8. Probability of being a nurse is 8 out of 13. The probability of being a male is 3 out of 13.
3 out of 13, I'm sorry.
So you get plus 3 out of 13. Now, when we did that, we counted somebody twice.
Yep.
Because when we counted the males, we counted this little green one up there. And then when we counted the nurses, we counted him, and we counted him again when we counted the males. We want to count everybody, but we don't want to double count anyone.
Right.
So we have to subtract 1 out of 13, and we get 8 plus 3 is 11, minus 1 is 10. So 10 out of 13. And then you can do whatever you want with that, whether you want to make it a fraction, a decimal, or whatever. But that's that part, okay?
And I think, Christy, he does usually have us make it. So it's 10 out of 13, and then that's 0.769, which is 76.9%.
Okay.
And then you have the next part, which is our next little number. And I don't know why it won't line up, but whatever. I'll figure that out. Well, Google Docs, I don't know. Google Docs does some interesting things. I haven't been able to figure that out. But anyway, if 2 of the 13 subjects are randomly selected without replacement. So we're choosing 2 people. What this means is we're going to choose one person first, then choose a second person from the remaining number.
Okay.
Okay.
That minus stuff.
So that's what replacement means. If I said without replacement, okay, then I would choose one person and I would choose a second person from the original number. Does that make sense?
Mm-hmm.
So the first person, the thing you have to understand about this is that the first person is chosen from the original group.
Ellie, turn it.
The first person is chosen from the original group of 13. The second person is not. The second person is chosen from the remaining 12. Okay, is that clear?
Yes.
So find the probability that if you do that, okay, if 2 of the 13 subjects are randomly selected without replacement, find the probability that they're both nurses and female. So we want the probability of female and female. Actually, we want female nurse and female nurse. Are you okay there?
Mm-hmm.
With what I said? Now, always when you're doing this, it is complicated, but try not to make it harder than it is. So start with the first person first. Find the female nurses on your chart?
Mhm.
Where are they?
7 over 13.
Right, that's the 7, that's this top middle number on my chart. There's 7 female nurses, and so the 7 female, this is the first nurse, 7 out of 13. That's the first one, right?
Yeah.
Now, because we're not replacing her, okay, she's off at the nurse's station getting a break after working a 20-hour shift, okay? So how many people are left in the group now?
6 over 12.
Well, there's 12 people left because she's gone, right?
Yep.
And one of the female nurses is now gone, so 6 out of 12, okay?
Okay.
And you multiply those together, and
That's what you do.
okay? So I would suggest that initially, I mean, you can do a lot of things to this, but I would suggest that initially you leave the fractions not reduced so you can see what happens with your numbers. So it's the number of people who fit the category out of the total for the first one, and then when you don't replace them and they fit in both categories, you reduce both numbers by 1. The 7 went to 6, the 13 went to 12. But this is 6 out of 12 is 1/2. So you're gonna get, you're going to get 7 out of 26 as your probability there. Okay?
So what is the 7 out of 26 is 26.269 or 26.9%? Because I just multiplied the fractions instead of trying to break them down.
That's fine.
Okay.
I just wanted you to see that, but that's how that works, okay?
Christy, do you get that?
Yes.
Does that make sense?
Yep.
Everybody good so far? Okay, part C.
Part C is the same as part A, yes?
If a staff person is selected, find the probability that the subject is a physician or female. Similar. You have to decide if they overlap, physicians and female, and they do, right? So you have to look at that term. So we have C.
5 over 13 plus 10 over 13 equals 15 over 13 minus the 3 that overlap over 13 equals 12 over 13.
Physician 5, female 10, 15, and then, yeah, minus 3 is 12.
So that's 0.923, 92.3%.
So this is 5 out of 13 because it's physicians. Then it's female, which is 10 out of 13 minus 3 out of 13. So you get 12 out of 13. Okay? All right. Now D says
100%.
if a staff person is selected, find the probability that the subject is male or female. Now, what's different about this one?
Well, this is all of them because they can either be male or female. So even if you added it and did it, I mean, it's just obvious it's 100%, but it would be 13 over 13.
Exactly. But what, right, that's true. But
So
what's
10 over 13 plus 3 over 13. 13 over 13.
Right. You're correct. I'm less concerned about the answer here than I am about you recognizing what makes this problem different from the other, say from A and C.
Well, it's two categories that don't overlap.
I'm hungry still.
Right. Uh-huh.
Okay, you're gonna have to wait a little while, okay?
She's always hungry, that girl.
I know.
So what's different about this is that, as you said, Jane, it's from two categories that don't overlap. So these categories, okay, we call them male and female, are what we call mutually exclusive groups. They don't overlap. Where on part A, which is why I made such a big deal of highlighting for you, right? These are overlapping groups. Or we say that they are not mutually exclusive. They overlap. So
Forgot all about that language.
when you have this nurse male minus nurse and male, right? We could conceivably do the same thing down here. If you memorize the formula, you could say, well, this is the probability of being male or female, right? So you would do probability of being male plus the probability of being female minus the probability of being male and female. But now, in this case, this is overlapping, right? So right here, this is 0, right? Male and female, there aren't any that identify as both. You see that?
Yes.
So when that happens, when that intersection is 0, we call them mutually exclusive events. So a little bonus question, because I can see him doing something like this. When events are mutually exclusive, when events are mutually exclusive, the intersection, that is the probability of A and B, is equal to 0. That's what makes them mutually exclusive events. Okay?
Mm-hmm.
Probability of A and B is equal to 0.
When
Okay.
they're mutually
They can't
exclusive.
happen at the same time. Yeah.
Right. Okay?
Okay.
Clear?
Yes.
Okay. So now let's go to,
That was A and B equals 0, or A plus B, or it doesn't matter.
they do matter because A and B is not a plus. And is
Multiplication.
multiplication.
Yeah.
So change it to the wording.
Okay. A and B.
Uh-huh.
And he uses those loopy things. U
The union and the intersection.
U is or, right?
Right.
The upside down U is and.
Right. Uh-huh.
Good job, Jane.
See it? She always says, I don't know.
I don't. It's the other stuff. That's the stuff Christy gets way more than I do. This is more charts that I used in business.
Oh.
What the heck? Okay, I don't even know. I copied and pasted and it turned into that. I have no idea.
Okay, so it is a physician given that it's a male.
I'm gonna have to, I know, but I need to be able, so what I'm gonna do is I'm gonna write, hold on. I'm gonna have to.
I don't see anything on the screen. Am I supposed to yet?
No, I will,
Okay.
I'll share it. I'm fixing it right now, Christy.
Oh, okay.
Because it says refer to the table in problem 4, position given male. So we want, and I'm just trying to type it up so that you can actually see it. But what I am gonna do, I'm going to, before I type that, is this helping you if I put it on the screen?
Yes.
I think so.
Okay, just asking. I'm gonna do something before I type. I'm gonna bring this down here. I haven't shared it yet because I'm still fixing it. So just bear with me for a second. Okay, so this is the same chart. And now we want to find number 5. We want to find 5A. We want to find the probability of a physician given that the person is male. Okay, so now let me, and B is male given physician, and then compare to see if they're equal. Okay, so then this is
2 out of 3.
Yeah, hold on, Jane. I'm not there. So if you think you've got it, that's fine. But
I'm not sure, so I think I do, but I'm not sure.
I need to because I'm having not technical issues, but I need to because I'm having to deal with 3 windows at the same time. I'm trying to like, okay, see if I can get, okay, so this is, and then B is find the probability of male given physician. Now let me down here do one other thing first. And that is, let me remove the highlights from there. Highlight color none. Okay, there we go. Because I want to be able to show you something. So when you have, there is a formula, okay? Let me share the screen, or this is not going to mean anything. So now you should be able to see it. I temporarily took off the highlights. Okay. Can you see the screen?
Mm-hmm.
Can you see it's the same chart. I just copied it and brought it down here.
Yes.
So you could look at it again. Now, if you're looking at the chart, it's really easy to do these. These are called conditional probabilities. And what they do in practice is they narrow the sample space. Well, now, what do I mean by that? Remember that our sample space, I'm sorry, what?
I was going to say, because you're choosing out of that given column.
Right, so they narrow the sample space. I always compare it to, think of binoculars. They narrow your field of vision.
Oh,
So instead of talking about the whole 13, we're going to talk about this condition. Now, here's the other thing. The condition part of it, the condition comes to the right of the line. So you see this word, and we read this as find. This is find the probability.
You guys, I'm going to disappear for one hot second because I forgot I got to move my car. It's street cleaning.
Okay, go do it.
Thursday, right? I don't even know what day it is.
It's
yeah,
Thursday.
it is. Go.
Okay. Hopefully they didn't get me. Yes.
Christy and I will make small talk while Jane is gone.
Yeah. I'm taking your notes.
No, that's fine. That's fine. And I'm going to provide the notes with, I'm recording this right now because nobody else is here.
Okay.
But if somebody else comes, I'm going to have to squelch the recording.
Okay.
But I'm going to provide the notes to you, so don't worry about it. I'll make sure that I put them in the email so you'll have that too, because I know you guys take notes when we have tutoring sessions anyway.
Yep.
But I'll provide these for you too, so you can look at it.
Okay.
You want to go feed your daughter while we wait?
She had another snack. She's okay.
Oh, okay.
She'll eat all day long if I let her.
Okay, no worry.
Oh, you know what? While we're here, do you have? So Jane, she was listed as my note taker for statistics. Even though I took my own notes, but she shares hers with you. But anyway, so she was able to get priority registration. And I had a meeting with my specialist this morning and asked about that, and he said that since everything's like online format, they're not really having people be designated note takers. So that means that she can't get priority registration, even though she may still share her notes with me. Anyway.
But do you still need, because they're still providing accommodations, I think.
Oh no, I got my accommodations, but I didn't know if you knew of any other ways of things Jane could do to get priority registration for the fall.
Oh, I haven't really thought of it.
Okay.
But yeah, I need to get on it because it's supposed to be out in June. Let me look into that because I don't have an answer for you, Christy.
I figured you were, you know all the tricks of the trade, so maybe you would know.
Yeah, and some of those tricks are now out the window and being So, yeah, but that's a really good question. I'll look into it and I'll find out.
Because she's taken all those classes that are really hard to get into, microbiology and all that.
And I found some resources. I didn't share them yet because I don't know how good they are, but maybe once you guys get through the 17th, maybe between the 17th and when your summer class starts, because I know Jane's taking a class in the summer.
Yep. We're taking chemistry the second session.
Oh, the second part. No, I found some really good chemistry lectures.
Oh.
Yeah, I found some really good chemistry lectures on YouTube. I just don't know what your level of chemistry is compared to the level that I'm listening to.
Yeah, ours is like very basic, like the first chemistry we take, but I don't know what that means.
Exactly. So I found some really good chemistry lectures online.
Okay.
Some of them are on YouTube, but I also found some virtual chemistry labs.
Oh, cool.
That show you, in some cases, they show you the actual, the person is actually doing the lab.
Oh, that's neat.
In front of you and okay, yeah. Here's the reagent, here's the, you pour it in, you do the thing. So it's not like you doing it, but at least you're actually seeing.
Well, yeah, I think both of us are visual and we learn better that way. So that may be very helpful.
but I was listening to, and that's why I was encouraging you guys, and you might have to listen to it in segments because it starts about 20 minutes into it, and he gave you the timestamp where it starts, but it goes on and on. But one of the things they talk about is that some of the students in the labs, like in the labs this semester, are complaining that they don't understand what's going on in the lab, and I'm like, if you had somebody in front of you actually doing it, like, I would think that would be a lot easier to,
Right.
to follow. Like, okay, we put this in here, we set it up this way. So I did find some resources, but I didn't know if that was concurrent with the level that you were on.
Got
because it does get harder, and I really wanted to talk to Samantha because she's had way more chemistry. I don't know if you remember Samantha, but she's had way more chemistry. So I thought that would be useful for that. But I do have that, but I'm going to look into your question because I don't know the answer to it.
Okay. I do remember Samantha.
Yeah, I've talked to her a few times since the hiatus, but I haven't talked to her lately.
So she hasn't needed your expertise?
A couple of times. She texted me and was like, "Hey, can you help me? I'm really stuck here." And one time I sent her some screenshots, and we had a phone conversation for like 20 minutes. But she's not really, like, her teacher is doing an asynchronous presentation, so he does videos for them, but it's not during class time. So they watch it. It's like an assigned video that they each watch. And then what he's done is he kind of did the flip of what my professor did. He, instead of making the class time optional and the tutoring more mandatory, he flipped it. So he basically tells them, watch the lecture anytime you want before the assigned class time. They have like a week because he does like one a week. So just watch it before you come to class or whatever. And then he has office hours where he answer. Yeah, so he did it that way, which I think is kind of cool, actually.
Are the professors still supposed to offer the office hours like they did before?
Yes, they have. Yeah, they have to be in. They have to be available to you a certain number of hours every week.
So, okay.
Either via chat, via.
Professor, he should be able to do that.
Well, I mean, it doesn't have to be okay. So,
I mean, we've just been communicating through email, other than when we are in front of him during our Zoom class.
They have some flexibility in how they can deliver office hours.
What I'll say is that he definitely hasn't offered it or mentioned it.
But they have to be available to you a certain number of hours every week.
Got it.
So as long as at this point, like, I think they're being a little bit lenient because, like,
I know it's all different for everybody.
As long as you're getting the help you need, that's the big deal. The other thing is, I was thinking about. It wouldn't necessarily apply to you guys because you're not writing a lot of papers, but the library staff. I don't know if you saw it. This was on the main webpage. The library staff is making themselves available 7 days a week, like 8 hours a day, for help with your research and your research, your projects. Like, even like, let's say you need to find like a book for an experiment or something that you're doing, because occasionally you need to write the lab report or whatever.
I lost you for a moment.
You can send. Can you hear me, Christy?
Yes.
They're offering researches, so you can either email them and they'll get back to you in real time. If it's off hours, they'll get back to you the next day. Or in some cases, they're doing on-the-spot Zoom meetings. So you chat with them and they're like, oh, this would be a lot easier if you Zoomed. So they are trying to make it easier for people who are doing papers and whatnot to try and put their research together. So that's another resource, because a lot of people forget that the librarians are professors too, you know?
Yeah.
So you might chat with the librarian and be like, hey, I need to know about, reactions in organic chemistry. And if you happen to get a librarian that has a background or a reading interest there, then, you might, sometimes you find out stuff.
That's cool.
But yeah, that was something new that I hadn't seen. I just saw that yesterday. Cool. Is Jane back yet? Are you back, Jane? No?
No, I just texted her, but she said we can move on and she'll just catch up.
Oh, okay. All right.
We can continue with this one, I guess.
So when you're doing this, you read this as find the physician, find the probability that the person is a physician given that the person is a male. Now, this, given that the person is a male, this is what you want to pay attention to. I'm going to put that in red. Given that the person is a male. So this red condition right here, you want to match it to this.
Okay.
Given that the person is a male. So I'm going to yellow. Actually, I do like a red color, but that's not gonna work for you. Let's do a darker red. Okay, so given that the person, see this? So you match this condition. Now you ignore the rest of this.
Okay.
You focus on the red. Given that the person is a male. So now it says, find the probability that the person is a physician, given that the person is male. So we're looking at the red, and you look at the physicians right here. So we're going to go with this group here.
Yep.
And we look for, given that the person is a male. So we're looking for that.
On the bottom?
I'm sorry, what was that?
Given's always on the bottom.
The given that the number there is on the bottom, yes.
Yes, okay.
So we write physician given male equals, now this is the formula, the probability of physician and male divided by probability of being male. Notice that what I said about binoculars, this is not the whole sample space now. This is just the males. So this is actually two probabilities that reduce to, as Jane said, 2, because there are 2 male physicians out of 3 males. So this is 2/3. Okay? Now, the thing that he wanted to make clear, I think, in the other part of this, is that when you reverse it, when you reverse the words, then it's not the same, it's not the same probability most of the time. Sometimes it reduces to the same, but it's not the same group. And I'm going to show you that now as soon as I figure out how not to underline you. Okay, hold on. Let me text color. No. Okay. So, oops. No. Let me do one thing here. It went away. Let me go back. Undo that. How do I make you go away, black? Maybe. Okay. And then I can make you go back. I don't underline you anymore. I don't want to underline anybody. Okay. So now we're back to that, right? So this is just so you can see the difference. Now this says, this means we want to find the probability of being male given that the person is a physician, okay? So here, you're given that is different. So here you have, given that the person is a physician, this is your
Out of 5.
red. Now you're looking at, given that now your focus, your binoculars go here to this group. Okay, so this is now red. Does this make sense like this? You see that?
Yep. Is it going to be 2/5?
Yep.
Probability of being male given that, yes.
Right. Okay, I understand.
Okay. Now
Yes.
there's no formula attached to that, but when you're doing the charts, that's the easiest way to go about it. This is equal, this is equal to 2/5.
And we should still put that in percentage form, right?
Yes, that's what he had us do. So I do the 2/5 equals 0.40 equals 40%, and that's the way I would write it. So you have all your bases covered.
2/3 is like 66.6%, right?
Yep. So I wrote 2/3 equals 6 bar, 0.6 bar.
66.7 if you round, 0.67, 66.7%.
Oh yeah. Okay.
I didn't do that, so that's a good call.
But it should always be like with a decimal, right? We don't round it up to 67 total, do we? Or can we?
No, you make it 66.7.
Okay, yeah.
So you're rounding to the nearest 10.
Okay.
Okay, so now the next part of this says, the next part of this says to compare your results. So we compare the results here.
Not equal.
We have a 2/3 and we have a 2/5. So yeah, and this is basically his point that
and then
probabilities, huh?
I was gonna say I'll answer number 6, then Christy can do number 7.
Funny. I already answered number 6.
So funny. Darn it.
It's just multiple choice.
Yeah, I know.
Oh no, TVs are next.
Okay, I'm running downstairs to get my water, so just ignore what you hear.
Did you have a timer go off to drink water? Oh, she left.
Let's all drink water.
No, seriously, she's hilarious. She lives off of a timer, and you know what? I should do that.
No, I know, but it helps.
Because I don't drink enough water, and if I have a timer go off, I say, drink water. That's a good idea.
There's an app on your phone.
Is there really? There's an app for everything.
Yeah, I forget what it's called, but there's an app on your phone that will remind you to drink water.
Yeah.
I just put my water in the freezer. That's why I had a timer.
Oh.
So
Got it.
Sparkling bougie water that I like as a treat.
Sparkling what's water? Bougie water?
Bougie. I call it bougie water.
Oh, the mineral water, right? Is it mineral water?
It's carbonated.
Oh. Is it flavored?
No, I don't do flavoring.
Okay.
Okay.
What about the natural ones, supposedly natural ones like LaCroix? Do you like those? Or you don't drink those, right?
They have flavoring in them.
Well, it's supposed to be, it doesn't have any calories or anything, but I don't know what they really add.
There are things that don't have calories that aren't good for you. Diet Coke, you know.
True.
It's just.
And you know what? If it has a certain, like, it could still have calories, but it's like minute and they don't count it or something. Anyway, back
better
to
drink regular Coke than Diet Coke.
Yeah.
I like Diet Coke better, but anyway.
Don't let Brian hear that. He's harping on that all the time.
I will not say it loudly. Okay, number 7.
Okay, number 7.
Okay, so
6 was just multiple choice, and the answer is D.
And I was in charge of that, and I got it right. So Christy's in charge of 7.
Okay. Well, this is similar, I think. No, not really. Okay. Not work, do work, don't work.
So I did this one, and I don't know if I did it right. So you received the shipment of 6 sets, and 2 are defective. So you want to find out the probability that both televisions work. So do 4 out of 6 times, then.
Okay, wait. You received a shipment of 6 and 2 are defective. You're selecting 2. Find the probability that both were okay. So you said?
So I said 4 over 6 times 3 over 5.
Right.
Assuming that there's no replacement.
Right, because this is let me channel Professor McDell for a minute, because we have the same problem as an example with a different number of objects, and she always says, if I took one out and it was defective, why would I want to put it back?
Right.
Select it over again. Like there's no.
Is this multiplication then?
Yeah, it's very much.
It's always multiplication when you're not replacing, right? Is that true or no?
Well, and is multiplication when you're doing probabilities.
Okay. So 4 over 6 times 3 over 5.
Correct. That's what I did.
Okay.
Yeah, that's correct.
For some reason, B, I was like, not sure if I was doing this right. Would it be 2 over 6 and then 1 over 5?
Okay, well, not exactly. So let me show you. Let's do something here. Now, you don't have to do it this way, but this will probably help you. So make a little sample space, kind of like we did before, of your options, okay? So I'm going to insert a little table here.
I'll be right back. I have to get a new eraser.
Okay.
No worries.
I'm so surprised that none of your students are showing up when exams are so close. How is everybody not studying like multiple hours per day?
Well, they might be, but the thing is, you have to remember, she provides the reviews at least. I mean, the reviews have been up for 2 weeks.
Yeah.
She provides the full review. She has a video with just about every section. And she provides full solutions while you're studying.
But they also have you as a resource. I would do all of it.
So I understand that. But what I mean is, like the solutions that you had, he waited to post. Hers have been up for 2 weeks.
Yeah.
So, not that you don't have questions. They may be emailing her for all I know.
Right.
You know what I mean? Because she is super responsive, especially like, I would say from the morning to the early afternoon, she's very responsive. She kind of takes the night off and she'll look at it once, but if you come in after 8, she'll see it at like 5 in the morning, you know? But she provides a lot of asynchronous supports like that. Her slides like, because she's had to convert all this to like an asynchronous non-lecture, because she doesn't lecture, but she provides videos that give you that, but she also provides full solutions to all of her lecture examples. So basically, if you read the book, you watch the video, then you look at her PowerPoint slides, or you look at her slides during the lecture, she provides full solutions to all that.
Well, then why are you embedded in her class and not ours?
Because
yeah, how does that happen? Does the professor choose to have you?
Yeah, the instructors request, and they get a certain number of requests. Like the tutoring center gets a certain number of requests every semester from the professors, and they'll try and accommodate that. And they really do try, and they really prioritize embedded tutoring. But it really also depends on the format of your class and what your professor prefers. I mean, Professor Nickdell and I have worked together for a really long time. And she's one of the, actually, she was one of the two people to pilot the original program. She was, and so she's a firm believer in that. But also, like, what I'll tell you what she doesn't have in class, not that she won't answer a question in class, because she does. She does answer questions if they come up in class, but she covers so much material in a class period that she doesn't have time to take 15, 20 minutes to answer questions in the classroom. Oh. So if you have questions about the material, you should be emailing her. You should, now she'll bring it up if it's something that, like, I'll send her an email and say 15 people asked me this, or 6 people asked me, she'll address it. But I mean, she's not going to take dedicated time to answer. She does make exceptions occasionally if she sees that the students are working, but that's why she believes in embedded tutoring, because it's all there. It's not that you can't ask a question in class. Right. It's just that she doesn't take time to, she'll ask if there's, and if there really are questions, good questions that people have, and it's really obvious that you're not getting it, she'll try and explain it and make sure that it's happening. But it's not something that she does on a regular basis because she needs to cover the material. Chapter 4, the probabilities section, is an exception to this. She's experimented every single semester for like 2-3 years, I think, on how to teach the chapter to improve performance. And one of the things she did this semester was she changed the way not the way she presented the sections, but like the breakdown of the sections. She changed that, and she built in additional time for students to ask questions about the homework, because those are the sections that I've had people come in and they can't do one problem from the homework because they do, and they have the notes and they've done the lecture and they can't do it. But then this was also the semester where even when we were on campus, nobody was asking questions. It's been the weirdest semester in that way. Nobody was asking questions.
Good thing you have your own fan club and me and Christy.
So, well, and the guy that I said comes to pretty much every, he does. He comes to every, the lady that I had yesterday was her first time, but she was here for an hour and some change yesterday.
Oh, that's good.
So, it's a matter of whether or not, but she's always like I said, if you needed to do that, she would find a way to get it done. As people were asking her questions that were actually valid and not just trying to like slow down the class so that it, you know what I mean?
Right.
As long as she thought that it was worth answering, she would, because I've seen her do that. She'll find a way in that case to speed up some other way or to compress the material some other way, but she will always cover the entire course. She's not like, she hasn't gotten rid of anything in the course, even with the 1 week spring break and the extra week that we had off.
Ooh, tough.
So, you know, but she spaced it out. She did. She rearranged the spacing of the lessons and the modules and all of that. And she's been a little more flexible with guidelines than she would have normally been. But I mean, that's one thing I like about her. But the thing is, in her class, you do learn, but it is death by detail. You have to be really organized in her class, because if you're not, you're going to die. Like, and you have to be really dedicated, because it is a lot, and it is occasionally overwhelming, even for me, and I've been in the class before. You know what I mean? So you just have to pace yourself a bit. But if you're trying and you go in and you communicate with her, she will bend over backwards to help you. She really will. She will bend over backwards to make sure that you have what you need. But she has kind of it's hard because sometimes people think that she isn't, like they're afraid of her, and she's really not mean. She just wants you to learn. That's the bottom line. If you're interested in learning, like I said, she'll bend over backwards to help you.
I have to go in about 15 minutes or so to do errands.
Yeah, okay. You want me to finish this?
Let's finish this problem, and if we have time, one more, Christy. Sure. So the other one's the fast, weird bar one. So okay. How do we do?
So find the problem. Okay. So if you look at, I'm not sharing my screen. Let me fix this.
Huh? I was just kidding. I said, stop being so stingy.
Well, we're both so nice to Shauna on her birthday.
Yeah,
on you, Christy.
It's a good thing you love me, isn't it? Otherwise, I'd probably be dead right now. So the first television and the second television, right? So here's your little breakdown. The first television works, the second one works. The first one works, the second one doesn't work. The first one doesn't work, and the second one works, or the first television doesn't work and the second one doesn't work. Okay, that's kind of the breakdown of how this. It says you receive a shipment of 6 TVs and 2 are defective. Now, this just gives you the breakdown. They're not all equally likely here. Okay, so you have to be a little bit careful. So I'm going to make a third column here. So now what we're going to do is, I didn't want one in the middle. I wanted it on the side. So what I want to do is, give me a second. Insert column, right. So in this case, the probabilities here, you have 6 TVs, 2 are defective. So that both work. So here you have 4 out of 6 times 3 out of 5, right?
Yeah, that's what I have.
Here you have the first television works, so it's 4 out of 6 times the defective ones. Now remember, there's only 2 defectives, so 2 out of 5, right?
Okay.
I'm doing the rows in my table. This one is defective, so this is 2 out of 6. And then you have working here is 4 out of 5. Are we clear? I'm kind of speeding through this a bit. And here, defective is 2 out of 6 and 1 out of 5, right? With me?
Yes.
I think so.
So these are your probabilities, okay? Now, you want to find the probability that at least, okay, so the probability A that both televisions work, that's going to be equal to the first line that I wrote. That's going to be, you have 4 out of 6. And here you selecting from 5, and there are 3 left that work.
Right.
So in this case, they both go down. I'll let you work that out. Now, the probability that at least one does not work. This is why I wanted to show you this setup. The probability that at least one doesn't work. So every line on this table includes one that doesn't work, except for the top.
Right.
Does that make sense?
Mm-hmm.
So conceivably, you could do these, multiply all 3 and add them together, or we could use the complement. We could say that this is equal to, and this is something that we were doing yesterday. So the probability of at least one does not work equals 1 minus the complement, which is the probability that none, now this is a little weird, that none do not work. So this is a double negative. This is a little weird. None do not work means that essentially the probability that at least one works probability that at least one does not work equals 1 minus the probability that all work. Okay? So
1 minus 0.40.
12 out of 30. Yes. So you get, this is equal to 1 minus 4/6 times 3/5.
Okay.
Now, the other way to do it would be to multiply the probabilities together on each line, add up these 3, add up these 3 rows, the probabilities on these 3 rows, and then you would have it. Okay, so a decade ago, the barcodes on retail products were changed so that they now represent 13 digits. How many different products can be identified with the new barcodes? Repetitions are allowed. So
to the 10th power, 13th power, or whatever.
Okay, so we have 10 digits.
Yep.
Not 9 digits, 10 digits. What are they? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits.
Mm-hmm.
Okay. Now, you're making a 13-digit number, essentially. So you're essentially making 13 digits. So you have, let me see if I can do this like this. You make a 13-digit number Oops, no, insert table. One by.
You can say hi if you want. Or do that.
So you have, I wanted to, okay, let me undo it. Let me undo that. So you have a 13-digit number here, and you have 10 in that case. So the number of combinations is going to be 10 times, let me just use this, 10 times 10, and it's going to occur 13 times. So that's going to give you 10 to those with a superscript of 13. So 10 to the 13th power. And that's going to be your answer.
And then it's 1E13. So that's going to be.
So that means 10, that's 10 to the first. Second, third, fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12, 13. So
remind me, guys, how do I do that on my calculator? 10 to the 13th power. Oh, it's that little thingy.
It's a little up thing, like you're squaring it, but
10 with the caret, the little triangle without a bottom.
One above the divider, right? Division. That one or no?
It's what you do for when you're doing squared, Christy. So if you were going to square it, but instead of doing square, you do that little triangle, and then you do 13.
Okay.
It's just going to give you, yeah, it's above the division sign.
Okay.
And then Shawana, really quickly, because he asked us this, but he on the test last time, but he said instead of repetitions are allowed, it was no repetitions are allowed. So how would you do that?
Well, if you had a 13-digit number, you couldn't. You couldn't, because there's only 10 unique digits.
Okay, I'll have to find his question then. But he did ask us basically that question. But
if I said to you something like this, if I said, well, make a 10-digit number.
Okay.
Make a 10-digit number. And repetitions are not allowed.
Mm-hmm.
Are not allowed. Well, I have 10 unique digits, right?
Mm-hmm.
There they are up there. So if in that case, I'm making a 10-digit number. So the first is 10, then I have 9, then I have 8. Because if I choose a digit, say I choose a 1, right? Then I can't choose a 1 anymore. So I have 9 digits left.
Okay.
And then I choose a 5. Well, now I can't choose 1 or 5, so I have 8 digits left. And you do that until you don't have any more digits because it's a 10-digit number. See? 6, 5, 4, and that's gonna be, okay.
So you just multiply all of those?
Well, the way you would do it on your calculator would probably be easier if you used factorial. So 10, and it's a little exclamation mark, 10 factorial. And the way you get factorial on your calculator is you go to math. You go to the math screen.
Okay.
So math is below alpha.
Mm-hmm.
Stay on the math menu. Right arrow over to PRB. It's right next to complex.
Okay, I see it.
And on the complex menu, option 4 is a little exclamation mark.
Okay.
That's factorial. So before you use it, though, you have to enter the number that you want to factorialize. So 10. So I don't know if that's a word. I made it up. you have to put in the number that you want to take the factorial of.
Oh, okay, got it. So I would go 10 exclamation point.
Right.
I would enter 10 first.
10 and then math probability.
Okay,
option
great.
4, and then it will give you that.
Okay. All right, yeah, because I remember like we didn't talk about it because he skipped kind of factorials, but then he had that on the test.
Yes.
And I remember because Christy, we even talked about it. It was like, maybe we should ask the opposite in case he asked it on the test. And then we didn't, and then he did it. And I was like, dang it, we should have.
Well, the thing is, okay, but now to go back to your question, just temporarily here, okay? Remember, now here's the thing about it, okay? You're not going to go to 0, okay? Because that would mean that every option was 0, and that's not true. So, but if you had a 13-digit number, okay, 13 digits, we don't have 13 unique digits. We don't have that. You see, we only have 10 unique digits. So if he said something like, you have the digits 0 to 9 and the letters A, B, C, then you could, you know what I mean? But you would have to have a sufficient number of unique characters to do that.
Okay.
If you were in with our number system the way it is, with the digits 0 through 9, we can't make a unique 13-digit number with no repeating digits because we only have 10 unique digits. Does that make sense?
I think so.
So you would have to introduce, if you know anything about, or if you can find anybody that's done any computer programming or computer science, they have number systems that are based on different numbers of digits. One is called the hexadecimal, and it's based on 16 digits. We can't write 16 digits, so what we do after 9 is we use letters. So their digits are 0 through 9, and then they go A, B, C, D, E, F. And that counts. So like the digit 11, because for them that's a digit. We write it as 2 digits. They have a digit for that. We don't have a digit for that.
Okay. All right. Well then, I think that's it for this time. Christy, any questions?
Nope, I don't think so.
All right. Enjoy your errands, and I'll talk to you guys later. Shauna, enjoy your